Hi class, today we are learning lesson 13.4, equations of lines, and we are continuing in the chapter of graphing. So the equation that you are learning today, it's called the standard form of the equation of a line. And it looks like this equation right here, ax plus by equals c, where a, b, and c are real numbers, meaning they cannot be fractions. And a and b both cannot be zero because it would cancel out in the equation. A also needs to be positive, and A, B, and C, they are all integers. Let's start with an example. 2x equals 3y plus 7. This equation needs to look like this. This is the standard form. So to get this in standard form, we need to move this equation around a little bit. We are going to move the 3y over to the left side of the equation, and this will become 2x minus 3y equals 7. Now this is the standard form of the equation of a line. Example 2, we have 3x equals 2y minus 4. Here we're going to move the 2y over. This becomes 3x minus 2y equals negative 4. This is the standard form of the equation of a line. What if we have a fraction? So in this example 3, this is negative 2/3 x plus 1/2 y equals 1. We can't work with it. We want to get rid of the fraction. So the way we do that is we find the LCD of both fractions. The LCD of both fractions is going to be 6. So we want to multiply each term in this equation by 6. So we're going to multiply this by 6, multiply this fraction by 6, and we'll even multiply this term by 6. So when we multiply 6 times negative 2, that's negative 12 divided by 3, that's negative 4x, and we get rid of that fraction. Plus 6 times 1 is 6, divided by 2 is 3y, and we get rid of that fraction. 6 times 1 equals 6. Okay, one last problem with this equation. We have in the first term a negative number, and we can't have a negative number. So we need to divide the equation by 1 to get rid of that negative number. So negative 4x divided by negative 1 is positive 4x. Negative 3y divided by negative 1 is minus 3y. Positive 6 divided by negative 1 equals negative 6. This is my standard form of the equation of a line. So now, here is another equation I need to introduce to you. This is the point-slope form of the equation of the line. So it looks like y minus y1 equals m times x minus x1. Now this should look familiar because you have seen a derivative of this in this equation. M equals y2 minus y1 divided by x2 minus x1. This is the slope. So this is just another form of this equation here. So for example 4, it says write the standard form of the equation of the line that passes through negative 1 and 4 and has a slope of negative 2 and 3. So you're only given 1 point and you're given the slope. So we're going to use this equation, y minus y1 equals m times x minus x1. Now remember, I suggest that you put your variables, make sure that, or put your x-axis, your y-axis points. And we are going to substitute these values into this equation. Y is going to be the variable, one of the variables that we solve for, minus y1, which is 4, equals, the slope is negative 2/3, x, we're going to leave it as that variable, minus x1, minus 1. I am going to change this into a bracket and then do my next step. So my next step is to solve what's in here, to simplify what's in the bracket. So this is y minus 4 equals negative 2/3 x plus 1. Now what I would recommend that you do next is to distribute the slope to both terms in parentheses. So this becomes y minus 4 equals negative 2/3 x minus 2/3. Now here we have a fraction, and we don't want to work with the fraction. We need to get rid of it, and we do that by finding the lowest common denominator of both of these fractions. The lowest common denominator is going to be 3 because they both have a 3 in their denominator. Now we multiply each term in this equation by 3. So this becomes 3y. 3 times negative 4 is 12. This cancels, and this becomes negative 2x. When you multiply these, 3/1 times negative 2/3, that cancels, and you're left with negative 2. Oops, I forgot to put the equals here. Okay, so we have 3y minus 12 equals negative 2x minus 2. We're going to bring our terms together and then shift this equation around a little bit to write it in standard form. So you can see we can bring our like terms together. The 12 we're going to add over here, and this is 3y equals negative 2x plus 10. Now to make this into standard form, which looks like this, we need to bring this negative 2x over, and we have a positive 2x plus 3y equals 10. And this is our standard form of the equation of the line when we are given 1 point and the slope. Okay, we have another example like this. So we have the point 5 and 6 with a slope of 1/3. So we have to write this in the standard form of the equation of the line. We are going to start with the formula y minus y1 equals m times x minus x1. Remembering that this is x1 and this is y1. So my y is going to be, we're going to leave it as y. y1 is 6 equals, my slope is 1/3, and we leave x as x, minus x1 is going to be 5. So my next step is I'm going to distribute. This is 1/3 x minus 5/3. Okay, so I've got two fractions that I need to get rid of. So I need to find the LCD, and the LCD of these two fractions is going to be 3. So I multiply every term in this equation by 3. Okay, so this becomes 3y minus 18 equals, these will cancel and you're left with x. These will cancel and you're left with minus 5. I'm going to bring my like terms together. So this is 3y equals x plus 13. Now, to get this in standard form, which looks like this, I need to move my x over. I'm going to subtract it onto the left side. And this looks like, we'll just move this up here. This looks like minus x plus 3y equals 13. Remember, I can't have a minus x, so I'm going to divide the equation by -1. Negative x divided by -1 is positive x. 3y divided by -1 is -3y. And 13 divided by -1 is -13. This is my standard form of the equation of the line when I am given one point and a slope. Okay, now I want to talk to you about how to write the standard form of the equation when you are given the slope and y-intercept. So let's look at example 6. Write the standard form of the equation of the line that has a slope of -3/4 and a y-intercept of -2. So remember, our standard form is ax plus bx equals c. Okay, so we're given the slope and we're given the y-intercept. This should jog your memory, and you should remember the slope-intercept form equation, which looks like y equals mx plus b. Okay, so we are going to substitute these values into this y-intercept form equation. So y equals -3/4 x plus -2. Okay, so here we have a fraction, and we need to get rid of that fraction. We're going to do that by finding the lowest common denominator. We only have one fraction. Our lowest common denominator is going to be 4. We're going to multiply each term by 4. Okay, I meant to put that in green. Each term gets multiplied by 4. Okay, so when we multiply this, we get 4y equals, this cancels and we're left with -3x, and then 4 times -2 is -8. Okay, so we need to shift this over to make it look like the standard form. So we're going to shift over the 3x, and we have 3x plus 4y equals -8. Okay, so this is my standard form of the equation of the line when I am given the slope and the y-intercept. I've got one more example for you. So write the standard form of the equation of the line that has a slope of -2/3 and a y-intercept of -4. So we're going to use the slope-intercept form equation, and I'm going to substitute my values. This is -2/3 x plus -4. Okay, so my next goal is to get rid of my fraction, and I do that by finding the lowest common denominator and multiplying all terms in the equation by the lowest common denominator. I've got one fraction. My lowest common denominator is going to be 3. I multiply all terms by 3. This is 3y equals, this cancels, and I'm left with -2x. 3 times -4 is -12. Okay, so now I need to shift over this -2x to make it look like the standard form. So I plus 2x plus 2x. This becomes 2x plus 3y equals -12. Okay. Okay, guys, so I would organize your notes. Make sure you know what to do in all three examples, and let me know if you have any questions.